The pyramid or Christmas tree problem can be challenging because of the frustrating nature of trying to combine numerical reasoning with strings as they're implemented in Java. Our goal is to make a pyramid of asterisks with n layers, and for some additional holiday spirit, we'll add 1 at the bottom for a tree trunk. Let's first try and think about how we could print this diagram out for n equals 5 without using loops. That way, we can find the patterns in our code and then generalize it so it'll work for n layers. Right away, we should realize that just using printline and 1 and then 3 and 5 stars will not work, because you end up with a right triangle, not a pyramid. What we need are spaces before each row of stars to properly center them. But how many spaces? The bottom layer is going to be the largest one, and it shouldn't need any spaces at all. The layer above it will need to be 1 space over, and then the one above that will need to be 2 spaces over, and so on and so forth. The top layer, for n equals 5, needs 4 spaces, since we started counting at 0 spaces, and we'll reach n total layers at a count of n minus 1 spaces. Alright, so now we've got something that looks like this. Print 4 spaces, 1 star. Enter. Print 3 spaces, 3 stars. Enter. And so on. There's definitely some repetition going on here, which means that we should be able to use a loop. Since what we want is for our code to work for every layer of the tree, we have to change the way that we use the print statement to depend on variables, instead of just typing the correct number of spaces and stars directly. Since the spaces and stars are behaving differently, we should probably separate this single print statement into 2 separate ones, the first for spaces and the second for stars. What's changing between each repetition of the lines is the number of each symbol. The number of spaces begins at 4, and then gets 1 smaller every loop. The number of stars, on the other hand, begins at 1 and goes up by 2 every loop. And this is where it gets difficult. We have to think ahead to our code in order to sort of put these instructions in terms that the computer can understand. There are 2 main ways to reframe the operations here. First, and the more intuitive way, at least for me, is to think of the things that we're printing as string variables, and to modify them as we go through each iteration of the loop. The stars string will have additional stars appended to the end of it, and the spaces string will get shorter and shorter. Unfortunately, this method is quite difficult to code. If you still want to see it, I'll put up a supplemental video to show the difficulties that you're going to encounter if you go this route. The less intuitive, but more easily coded method is the one you're probably going to see in class. The main problem that the string technique avoids is finding a way to translate an integer to the amount of repetition of a symbol in a string. But just saying that kind of clues us into the way to solve it. It's repetition, so it can be done with another loop. Saying print space 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 is the same as saying print space 4 times. We just need to construct a loop that runs the appropriate amount of times, like we talked about earlier, spaces going from 4 to 3 to 2, and stars going from 1 to 3 to 5, and so on. To code this, try to keep each instruction compartmentalized, one of these comments. The easy part is first. We just need to declare spaces to be 4, or n minus 1, and stars to be 1. Next, we need to print those spaces, but by using the variable, not just typing space 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 space. We do this with a loop that runs spaces number of times. Similarly, we have a loop that runs stars number of times, or once for the first row. At the end of the star loop, we're done with the row, so we need to print a new line. Now, before the next loop run starts printing off the spaces and stars, we need to change the amount, spaces down by 1, and stars up by 2. Finally, we need one last loop that runs n number of times, once for each layer of the pyramid. After the loop is done constructing the pyramid, we need one extra little bit to reprint the very first line of the pyramid to create our tree trunk, as that line is identical to the first line of the pyramid. We can run our code here to make sure everything works, but there's one last thing we can do to take it one step further. Right now, we essentially have a counter variable for both spaces and stars that changes each iteration. However, there's a mathematical relationship between the correct number of spaces and stars and the number that represents which row we're on, I in this case. These are linear functions, as the rates of change are constant. Because the initial value of the number of spaces is n minus 1 and the change per iteration is negative 1, goes down by 1, the equation should be negative I plus n minus 1. For the number of stars, the initial value is 1, and the change is up 2 per iteration. So the formula is 2i plus 1. We can get rid of our counter variables this way and have what some might consider an even cleaner solution. To me, even if it's mathematically prettier, it does feel a little bit harder to read as code. It's entirely personal preference at this point, though. What I'd like to stress is that there can be many solutions to a given problem in computer science. What's most important is finding one that works for you and improving it using trial and error. And I really mean error. You're going to find a lot of things that do not work, but it's going to help you to work towards something that does.